Well, welcome
Alrighty.
to another session for JNation, the 11th on this track with Josh Long. He comes from Pivotal and is going to talk to us about the reactive revolution. So, Josh, how are you today?
My friend, I'm doing quite well, thank you. All things considered, I'm very sad that I could not actually be there in person this year. This is the second year I have wanted to be there and had a reason to be there and still couldn't. Last year, my daughter graduated junior high, and this year, the pandemic. So I'm so happy to be able to talk to you all, but very sad that I couldn't be there in person.
Let's hope next year we can have you in person.
Yeah, please. I mean,
okay, so you are going to talk to us about the reactive revolution.
Yes, sir.
Go for it.
All right. Thank you so much. Good morning, good afternoon, good evening, everybody. I appreciate you all being here. I know that you've got a lot of places that you could be, but you chose to join me and us this morning and this evening, this afternoon. So thank you for that. We don't have a lot of time. I was just told it's about 50 minutes, 50. So that means that we have very little time and a lot of stuff to cover. So please take a note of this Git repository, all the stuff that you see here. Take a note of these coordinates. That's going to help you find me later on. If you have questions, comments, feedback, whatever, I am happy to engage. I'm happy to help. And of course, take a note of that Git repository there. If you have questions, comments, feedback, whatever, you can find that there. A little bit about myself. My name is Josh Long. I'm a Spring developer advocate on the Spring team, and I have been since 2010. I've got a number of different training videos on the internet that you can find. I wrote a book called Cloud Native Java, which is all about how to build applications that survive and thrive in the cloud. And of course, I've got a podcast that I do every Friday called the Beautiful Podcast. And I have a blog that I do every Tuesday called This Week in Spring. So I have to still write that today. And I do a screencast every Wednesday called Spring Tips. So this is just me at a keyboard looking at different corners of the ecosystem using Spring Boot and Spring Cloud and all the rest of the Spring ecosystem. And of course, I have a new book called Reactive Spring. And that's the topic that we're going to focus on today is the contents of this book. So yes, you can buy the book. Maybe you don't need to. Maybe you can just listen to this presentation and get all the fundamentals that you need, and then you'll be fine. So what we're going to talk about is reactive programming and why we care about reactive programming in the Spring ecosystem. For most of us, for the last 20 years, we've used synchronous and blocking input and output. And this has worked okay. And if we needed to scale synchronous blocking in input and output, we could easily add other nodes to our load balancer and scale horizontally. The problem has become that when we look at most of these computers using this traditional approach to input and output, we see that they are mostly idle. They're just doing nothing. They're sitting there waiting for something. And the CPUs are all busy. The CPUs are not busy, and yet we can't handle more threads. We can't handle more work. That's the first problem. And the reason is because if you look at the lowest level code, you look at the Java threads, they're in a wait state, waiting for input to happen on those input streams. They're blocked. They're just, somebody called input stream.read, and the code is no longer able to execute beyond that line. And so they're waiting for a response that they're not going to get. This is a problem. The other thing that we realize if we look at this code, and if we look at these kinds of services, is that increasingly we're moving to microservices. And this means that we're doing communication over the network, communication that can often fail, that experiences latency, that experiences rate problems, right? The speed at which one side moves might be slower or faster than the other. So all these things contribute to a situation where communication is kind of scary if you're doing communication over the network. And we have no good way of describing that complexity and handling it in the traditional approach to doing input streams and output streams. So what we need is something that allows us to free up those threads, to wait for, to ask for data, but to not wait on the thread, right? And then we need something that allows us to communicate with other services over the network in a more reliable way. And so this is where reactive programming comes in. It gives us a programming model that inverts the normal paradigm for input and output. Instead of us pulling the data out of an input stream, the producer of the data pushes it to us. And then when it's ready, we can process it, but we don't have to wait for it, or we don't have to sit there asking for it. We can do something else in the meantime. Reactive programming also gives us a paradigm called reactive streams, which allows us to better describe possibly flaky, possibly unbounded, possibly latent, asynchronous network communication. And so these things make reactive programming a natural fit in today's world. Of course, in order for this to work, we need to have an ubiquitous data type and an ubiquitous programming model, something that all of our services can use in a common way. This is where the reactive stream specification comes in. These 4 very simple types were introduced by the Spring team, by Lightbend, at the time they were called TypeSafe, by the Eclipse Foundation, by a number of different organizations. Netflix, of course, the ArcJava team. All these different organizations got together and we extracted out these common ground interfaces. On top of which, we have since released a library called Reactor. Reactor supports building reactive pipelines. It's pretty useful, but it is just the beginning. On top of that, we have released integrated support in Spring itself. And that, my friends, is the journey we're going to see today. We're going to see how all these different things plug together. And of course, in order to do that, we're going to go to my second favorite place on the internet. Obviously, my first favorite place is obviously production. I love production. You should love production. You should go as early and as often as possible. But if you have not been to production, you can begin your journey here at start.spring.io. So what I'm going to do is I'm going to build a brand new project using Spring Boot 2.3. I'm going to call this the service. And I'm going to use Java 11. I have a number of different choices here for the version of the JVM that I'm going to use, but I encourage you to use the latest one. Actually, let's just use Java 14. That's the current supported version of Java. That's the least version that you should be on, unless you are a coward, in which case you should use Java 11, which is the current long-term supported version of Java. Either one of these is fine, but Java 8 is not okay. Java 8 is to be avoided at all costs. Remember, this is a very old version of Java. It's technically inferior. It has less features, it has less performance, less security, less reliability. It's also morally the wrong choice. I ask you, my friends, how do you think your children would act if they knew that you're still using Java 8 in production? Are you ready for that conversation? Don't you think that the look of depression and shame in their eyes would be too hard to bear? I think it would be as well. So we're using the latest and greatest version of everything because we can. I like Spring Boot 2.3. There are a lot of features in Spring Boot 2.3 that I think are particularly interesting that further cement Spring's position in the cloud, right? It's #1 position in the cloud. One of my favorite features is Docker support in Spring Boot. So Docker, Spring Boot, fill web, okay. This support means that now I can just go to my build. I can create a new Spring Boot application and just do Maven Spring Boot -build image, and it'll automatically generate a container that runs through the Cloud Native Computing Foundation's build packs specification. So it'll create a consistent Docker image that you can then just deploy to production, be it Kubernetes or Cloud Foundry or one of the other container orchestrators out there. Okay, that's one of my favorite features. Another thing that I really like about 2.3 is that we have the ability to create applications that work very well with the Spring Growl feature. Okay, so we released a feature for Growl VM. Now, Growl VM is a just-in-time compiler. Well, that's pretty amazing. What is that? Oh, there you go. It's a just-in-time compiler that can be used to replace the existing C1 compiler, a just-in-time compiler in the JDK. You can use that like that, or you can use something called native image support, right? The Substrate VM native image builder. So Growl VM has this secondary component. It's not the same thing as a JVM, but what it does is if you can build your application in such a way that you isolate all the different dynamic behavior in the application. So no proxies, no reflection, no dynamic class loading, no resource loading, etc. No jar loading, basically, no resource loading inside the jar. If you can isolate it or at least describe all of that, then you can build an application that compiles to a native image. I'm not going to show you this particular thing live because it takes forever. I don't know if you have seen the old XKCD compiling sketch, right? This cartoon where compiling, this one, right? Very famous, amazing cartoon from XKCD. The #1 excuse for legitimately slacking off, oh, my code is compiling, it's the original version, somebody overwrote it, right? So that's the same situation we have here for Growl VM. But I have already done this. So if I go here to CD code spring-tips Spring Growl native image feature, and by the way, you can watch me do this and you can learn more about it in this article, Spring Tips Growl native image builder feature. I have a video as well as a blog, so you can read both, you can watch both, or read one or the other or whatever, okay? So I've got two different versions of the application here. Let's just look at the reactive application, okay? So here's the code. It's an application that starts up in around a second. You're gonna see me create an application just like it later on. But I've also taken the time to compile it, okay? So there it is in there. There you go. So it's 0.14 seconds, right? And remember, my CPU is being used because I'm screencasting. So normally that's about a second or less, right? It's very, very, very quick to get that application up. And that's talking to a database. It has an HTTP endpoint. It's doing all the normal stuff, right? So Control-C that, refresh, nothing there, right? Now, very, very quick, very lightweight, tens of megabytes instead of hundreds of megabytes for the typical Java application. Starts up virtually instantaneously, certainly faster than you can perceive, and very, very interesting option for the cloud. So you can use this in conjunction with Docker. Julien Dubois over at Microsoft just did a demo just last night where he talked about using Graal VM compiled Spring Boot applications in Microsoft Azure functions, right, to do function as a service kind of processing. The use cases are infinite. I encourage you to check it out. So all of that is enabled thanks to Spring Boot 2.3. So let's go ahead and build our service. In our service, we're going to have a few features here. We're going to have the reactive web support. We're going to have R2DBC. We're going to have MongoDB. We're going to have Lombok. We're going to have OurSocket. Okay, so a number of different dependencies here. Spring Boot, the web support, R2DBC, MongoDB. Oh, we need a Postgres instance. Okay, so I'm bringing in a number of different dependencies. I could choose to add them myself. I can just scroll through this very, very long list of things. And you can see that we've got support for Google Cloud and AWS and Alibaba and Microsoft Azure. We've got support for Kafka and all the different message queues and integration technologies and Apache Camel and Spring integration. We've got support for just everything, OAuth and OIDC and JOT and all that stuff is there, okay? So now we're gonna go ahead and hit generate, and we're gonna generate a brand new service, and I'm gonna open this up, okay? So let's go here, CD downloads, UAO, and I've got a little command line program I wrote called UAO. It's unzip and open. It'll unzip the file and open it in my IDE. Now, naturally, most IDEs, including IntelliJ, including the Spring tool suite, which is our Eclipse distribution, and including NetBeans, have plugins that you can use that actually talk to the same service that I just showed you. So if I go to my command line, did you know that start.spring.io is also a web service, right? So you can go here, oops, okay. There you go, right? You get the response. So you get ask out from that. It's also a REST API. So lots of different things you can use to get data out of there. Either way, the IDEs all plug into that basic mechanism. So you can use it as well. So let's see here, friends. I've got this application. I'm going to make the font a little bit larger here. And what we're going to do is we're going to build an application that talks to a database. Now, I've got two different databases on my local machine. One is Postgres, or at least I think I have it running. Let's just make sure here, huh? That's fair. PSQL orders, okay, good. And I've got MongoDB, okay. There you go. So what I'm gonna do is I'm gonna build an application that talks to MongoDB first. So let's do that here. Okay, drop, goodbye. And I'm going to now comment out R2DBC. We're gonna come back to R2DBC in a bit, okay? But for now, let's just comment this out. We don't want JDBC, that's needlessly slow. And blocking synchronous, right? So there we go. There's our application. I'm going to re-import the dependencies so that we only have MongoDB on the class path. Now, this service application is going to be an application that writes data to the database. Okay, so class reservation, and this database is going to have a single primary key here called ID and another field called name. Okay, and we're going to say ID, and obviously this is going to be a document in MongoDB parlance. Now this is Java. I need getters and setters and all that kind of stuff. In Java 14, in the preview features, there's a new thing called record classes. So record, reservation, etc. And this gives you a lot of the things that Scala has with case class reservation, right? This kind of thing. And then of course in Kotlin, you've got data classes, right? So this is a very nice feature in Java 14. I talk about these features in my Spring Tips video, Spring Tips Java 14. If you want to learn a lot more about all the cool things you can do with Java 14 and Spring, I did this video, again, a video and a blog. So lots of interesting features, smart switch, case classes, multi-line strings, etc. So anyway, I've got this DTO, I've got this type. I want to create the getters and the setters and all that. For now, I'm going to use Lombok. Okay, hopefully one day I'll just be able to do record classes without having to enable preview features. And what I would like to do then is to write some of this data to the database. So I will create a repository. Now, a repository is a thing that handles asynchronous. Sorry, it handles the data manipulation lifecycle. It does the reads, the writes, the updates, etc. So you can see this interface is called Reactive CRUD repository. It has methods to support saving, finding, counting, deleting, etc. And it takes several different parameter types that may not be familiar to you. The first is a publisher. A publisher is a thing that produces data asynchronously that you can subscribe to. You can say, I would like to consume this data asynchronously. And when you subscribe the first time as a subscriber, you are given a subscription when you first connect, when you first subscribe. So this subscription is very convenient because, as we will see, it allows you to control the rate of consumption. When the publisher produces new records for the consumer, the subscriber to consume, the onNext method is called with each new record. The onError method is called whenever there are exceptions. And finally, onComplete is called when the publisher has run out of things to give to the subscriber. Now let's talk about the subscription. This subscription is an interface that this subscriber can use to ask for more data. So we can say, I want to request 10 more records. This is a guarantee that the publisher will never give you more than the data that you have asked for. So you cannot be overwhelmed or denial of service because you control the rate of the consumption. If you want to stop the production of data, you can cancel the production of data. So this is flow control. Ever since one computer was on the same internet, on the same network as another, they had to talk to each other, and this communication sometimes went faster or slower depending on the resources and the situation for each node. And so the network protocols that we use today have flow control built in. It's something that's part of everything that we do on the internet, and yet we don't really think about it in our Java code. This API gives us the ability to do that. This is called flow control, or sometimes back pressure. When you see people talk about back pressure, this is what they're talking about. It's the ability for the consumer to say, no, I don't want any more data, thank you. I'm busy. I'm too busy to handle anything else. There's a fourth class called a processor. Now, a processor is a bridge. It's a source and a sink, a publisher and a subscriber, a producer and a consumer. It's like a queue. Data goes in, data goes out. Okay, very, very simple type, but it's a very nice bridge class. Okay, now those four types are part of the reactive stream specification. I talked to you about that earlier. There are two specializations that come from Reactor, our project, that support even more refined use of these reactive types, because as interesting as those types are, they're still very basic. So the first type is called a Mano. Now, a Mano, if you speak Spanish, I know you speak Portuguese. I'm not sure if it's the same in Portuguese, but in Spanish, this means monkey. That's not what this class means. It's different, okay? In this class, it means we have one record, just one single object. So it's 0 or 1 record at most. And then we have a flux, and a flux produces 0 or more records. So this is like a Java 8 stream, except it supports back pressure and it's push versus pulled, right? Now, we have these simple types. We have these simple types to help us understand, hey, I've got more than one record, or I've got just one record, like the equivalent between the analog between a completable future and a Java 8 stream, except reactive. Now we've got these types. We can use them to write data to the database. So I'll say sample data initializer, and we'll say at event listener, application ready event class public void begin. Okay. Now, this is just a Spring Bean that's going to start up when the application starts up. And this application will, when it writes data to the database, need a reservation repository. So I'm going to inject that into a constructor. I'll use Lombok to compile, to create that constructor for me at compile time. And so here, I'm going to just write some data. I'm going to write some data to the database. So I'm going to write people in the Spring team. I've got my friend Spencer. He's on the Spring team. I'm on the Spring team. We've got Madura. She's awesome. She's on the Spring team as well. Olga as well. Who else do we have that are my friends on the Spring team? Violetta on the Spring team, of course. And Yushin. Okay, we've got her as well. She's awesome as well. So who else do? Oh, Dr. Sire, of course, and Stefan. Okay, there you go. There's a bunch of people on the Spring team. Okay, so these are names for people in the Spring team. And what I'm going to do is I'm going to visit each name and turn it into a new reservation like this. That'll give me a reactive stream of names. Okay, so stream, and then I'm going to visit each one of those and turn it into a record that's been saved to the database. So like so, new this dot reservation repository dot save, passing in R. Now, what's going to happen is I am going to call map, and if I call map I have a save operation here. You can see it returns a mono of reservation. Well, that mono of reservation is going to be accumulated here into the map operation. So if I look at that, I have actually a publisher of reservation. I don't want two publishers. I want just one. So I need to take the inner publisher and then flatten it, kind of like the curve, which we're trying to flatten as well. So I'm going to use flat map, right? Flat map is going to push down or resolve the inner asynchronous stream, okay? And now I have saved data. Now, of course, the IDE is saying that that can be a Lambda. And there we go. Now, if I run this code right now, what happens? Nothing, right? Nothing is going to happen because I have not subscribed. So I need to subscribe to trigger the pipeline. Think of this as a pipeline with multiple stages. Each stage is connected together. Each pipe in the pipeline is connected together, but there's no water. There's no water that goes through the pipeline. So we need to turn on the faucet, turn on the water by subscribing. And when I do that, what I get is I get an application that will actually run. But if I run this program right now, what's going to happen? Well, first, I will have 8 records in the database, and then 16, and then 24, and so on. So I want to delete all the data first. So what I will do is I will say, delete everything, and then save the data, and then find the data, right? And then finally, subscribe. So system out print line. Okay, there you go. There's our whole pipeline. Now what I'm doing is I'm using these operators to say, do this asynchronous thing that may not happen on this thread. And once it's done, then save the data. That might be asynchronous. It may happen on a different thread. And then once that's done, then find all the data. And as each record comes back, write it out to the console. So let's go ahead and see what happens here. Okay, compilation, good. So our application's up and running. We have our 8 records in the database. So you can see, you can see that here, right? We can see the data here in the console in the application database, and we can go to here. We can see db.reservation.find, and let's just take something here. There you go. So there's the UUIDs that reflected in the output in the database. That's MongoDB. MongoDB is a very nice database. It's a document database, good for kind of document scenarios. But a lot of people ask, can I use SQL databases, right? And of course you can. We have a project called R2DBC. Now, R2DBC is a reactive relational database connectivity abstraction, right? It supports SQL-based data access. That's separate from our NoSQL based data access. Remember, each time we implement a Spring Data project, we have to implement it on top of reactive drivers. So sometimes you will see that we have Spring Data MongoDB, and then more recently, Spring Data Reactive MongoDB. These are 2 separate code bases. There are a lot of different reactive implementations out there already, though. So there's Spring Data for Azure Cosmos DB. There's Spring Data from Google Cloud Firestore and Google Cloud Spanner. We have Spring Data Reactive Cassandra, Reactive MongoDB, Reactive Redis, Neo4j, Couchbase, Elasticsearch. All of these have Spring Data implementations. I've just shown you one. Okay, now we have R2DBC. And R2DBC is going to talk to PostgreSQL. There are many different drivers out there. There's H2, Postgres, MySQL, Microsoft SQL Server, and a few others as well. So what I'm going to do is I'm going to change this code to now use R2DBC. Obviously, these are different domain models. These are different kinds of components. So they are going to be a little bit different in the way we code them because this is a trivial application. But if this was not a trivial application, then the code changes would be more extensive, okay? So there we go. There's my application. We can restart, re-import and restart. There we go. Okay, is it compiling? There you go. Compilation takes forever when you're on the seat, when you're zooming. It's just parsing Java. I don't get it. Okay, there we go. So now it's complaining that I didn't have the URL there. So let's actually put that in. We go here, spring.r2dbc.url. Okay, r2dbc, Postgres, localhost, orders. Okay, username, orders, password, orders. Okay, there we go. Take 2. So that's my local username and password. Don't tell anybody. Okay, that's just between us. I don't want you to give that away to the world. Now, here we go. So if I go to PSQL, I can say select all from reservation, and let's say Olga 947. There we go. Okay, so you can see her data is on the console there as well. It worked, right? We have data in the database. A very natural question then, of course, is can I do transaction demarcation? And the answer is yes. Yes, you can actually use declarative transaction demarcation if you want. You can just use add transactional just like you normally would. But you have to consider that this is a very interesting thing that it does. Consider how normal transaction demarcation works. Normally, in the old world, you have a thread local that gets created at the very beginning of the transaction, and the storage, the state for the ongoing transaction lives in that thread local. When the method completes on the same thread, the thread local is cleared. I mean, the transaction is committed, and then the thread local is cleared. In the reactive world, that no longer works because the pipeline might start here and then continue here and then end up over here on different threads. And so thread locals no longer work. So we have created a mechanism called the context. And you can use context. You can say key value, key to, and then value can be, whatever. It's just arbitrary. It's like a dictionary, a map. You can put whatever you want in there. And we'll make sure that that information lives for the entire life of the reactive pipeline. Okay, so now we have an HTTP endpoint. Let's build we have a data service. We've looked at the support there. Let's build a reservation REST controller. You've seen something like this before in Spring MVC, surely. This endpoint style is very, very familiar. It's nothing new. It's been around for years and years and years. And what it does is it maps that this endpoint, this method, should be called when there is a record to provide a response. So we can say return this dot reservation repository dot find all, and voila. Okay, that's a normal way to do it. I like that style, very natural. That works in the reactive world. But my favorite style is to use the functional reactive style. So router function, server response, routes. Okay, return route. Come on. Oh. Build. Good. So route.get /reservations, new handler function, server response.ok.body. And here I'm going to inject my reservation repository, RR, and we'll say r.findAll.reservation.class. So what I'm doing is I'm describing a reactive pipeline. I've got a predicate here. The predicate has a lambda. There you go. The lambda in turn can use static imports. So there's the entire HTTP GET endpoint in one line, as opposed to a whole class with methods and a constructor and storage and all that stuff. And this is a builder API, so I can do delete and options and put and all the normal stuff, right? Whatever you want, right? Okay, so we have now a functional reactive endpoint, and we have HTTP output. Let's go ahead and run this. Let's see what we get. Now, the thing you're going to think about is, hey, Josh, that's very nice. You've just shown me that I can run data. I can show HTTP data. I can do curl HTTP localhost 8080 / reservations. Okay, there we go. That works just fine, no problem at all. And that's 8 records, and I'm talking to a SQL database, and I can hear you go, who cares, right? Why do I care about this? I could have done this yesterday. I don't need reactive APIs to do this. I could write a servlet application talking to Hibernate, and that would be just fine to do 8 records with JSON and so on. Apache Tomcat and Hibernate, very, very common stack. Yes, you're right. That's true. But what I have shown you so far is not something that is unique to reactive programming. What I have shown you so far is that reactive programming looks and feels almost the same as regular day-to-day bread and butter traditional, blocking programming. Okay, you can see that we've got kind of a bit of a functional code here. This is very functional. In fact, you can string together these various things into one pipeline if you want, like that, right? That's fine. So reservation, or better yet, just use var, and this becomes saved. And it's just a very natural way to express your code. I would argue that this code looks about as complicated as Java 8 Streams code does, which is to say, not very complicated at all. Yes, there is a little bit of an upfront learning curve when it comes to reactive types, but I think that you will find that when you start using reactive programming, it's actually much simpler than the alternative. Now, what I mean by that is using reactive APIs is very convenient because you only have to learn this one API. If you want to do server-side events, you use publishers. If you want to do reactive data, if you want to do data access, talking to a SQL, NoSQL data store, you use publishers. If you want to do WebSockets, you use publishers. If you want to do OurSocket, you use publishers. If you want to use Kafka, yeah, you use publishers. What about RabbitMQ? You guessed it, publishers. You have one kind of type, one kind of stuff, one API. So now when you go into synchronous or go to synchronous or asynchronous APIs, they're all publishers. You've got one API to learn. So amortized over all the different APIs, this is actually much simpler. Instead of learning the different incompatible APIs and figuring out ways to glue them together, right? Now it's very easy. Have you ever tried to do WebSockets and JMS? There's glue code that you have to write in the old world, right? Now it's very simple. You just use a publisher. These things compose very nicely. And that's where things become really interesting, is when you start doing composition. This helps you, especially when you build microservices and when you build services that talk to things. So let's now take a look at one use case that is benefited by reactive programming, which is non-blocking IO. And then we're going to talk about microservices and their application here. So I've got an application that just reads data from an HTTP endpoint, not a big deal. One of the real use cases that reactive programming can help you with is whenever you're doing something that in the traditional world would use a thread. So a very common example of this is WebSockets. Okay, so imagine you've got an example, you've got a WebSocket endpoint that's producing an infinite stream of greetings. Okay, so I'm going to say @service class greetings service. Okay, or better yet, just greetings service. Okay, and the service is going to have an endpoint that that returns an infinite stream of greetings responses. Okay, so given a greetings request, here we go. Given a greetings request, we're going to return a stream of responses. Okay, so let's go ahead and create these types here. Class like so, class like so. Okay, there's our two types. Now a response is going to have these annotations on it, and so is that. A request will have a name that we're going to greet, and the response will have the greeting itself, the message. Okay, so there's the basic arrangement of our types. Our service is going to create a never-ending stream of data. So flux.from stream.generate, and I'm going to use the supplier here to create a new greetings request, and I'll say hola, and I'll use the name, get name, request dot get at instant dot whatever. Okay, instant to dot now dot to string. Okay, so there's our greeting. Okay, and maybe a little bit of booleation there. Good. Now, so there's our basic stream, our infinite stream. This is going to produce a never-ending stream of responses. Every single record that we get back will be hello and the current second. And if I run this program right now, it'll print out data down to the floor and out the door. So I want to slow it down a little bit. I'm going to use delay elements and I'm going to introduce time in my reactive stream. I can do this because behind the scenes, everything that is being controlled here is being controlled by a scheduler. And the scheduler is 1/2 threads and thread pools, and the other half is a clock. And so this clock and this scheduler can be used to control where your code executes and when. Okay, you don't normally have to worry about this. You don't have to worry about it at all. It's just done for you, right? You have a default scheduler that is going to just be created for you behind the scenes, but you can create your own, right? You have a default scheduler that has 1 thread per core, right? And that's fine because as long as you do not block the threads, everything will be okay. But if you have blocking interactions, as long as if you have blocking IO or blocking algorithms like Fibonacci or CPU bound algorithms like cryptography, things like that, then you need to make sure to isolate that particular blocking interaction on a custom scheduler, on a separate scheduler. It's very important that you never block a thread. Remember, each thread is an event loop, right? Just like a Node.js. So you need to be very careful that you don't block. If you have only, let's say you have 4 cores and you have only 4 threads, well, then if you block one of those threads, you're not blocking one user, you're blocking 25% of your users. That's a big problem. So we have created a Java agent for you called blockhound. You add it to the class path and it'll detect blocking interactions, things like thread.sleep, which will cause your thread to block. It'll detect it and throw an error for you, an exception that you can use to figure out where you're doing something silly and blocking the thread. So use this if you can, right? It's good to know about the scheduler, but the point is we don't really need to know about it most of the time. It's just fine unless you're doing something blocking. So now I've got my service and I want to demonstrate this to you. So I'm going to create a WebSocket endpoint. Okay, so configuration, greetings, WebSocket configuration at bean. So the first thing is that WebSockets are a binary protocol, but they get exposed to the client as HTTP. So the HTTP endpoint starts up, and then the client connects to that endpoint and upgrades to the binary protocol. Okay, so what I'm going to do is I'm going to tell Spring to create an HTTP endpoint called WS Greetings that maps to this WebSocket handler. That WebSocket handler is where our business logic lives. In order for that to be, in order for Spring to look for WebSocket handlers, we need to create a WebSocket handler adapter. Okay, so that's this. And then our business logic here is just WebSocket handler. Okay, return new WebSocket handler. Good. Now, this is a type that gets created when there's a new HTTP session. And when there's a new session, we can now, when there's a new WebSocket session, when there's a new session, the WebSocket service can ask the client for data. It can say, give me any incoming messages. I want to receive any incoming messages. So here I say, I want to receive a stream of messages. And for each new message that comes in, I want to turn it into the text. I want to unpack the text. And then for each one of those text messages, I want to turn it into a new greetings request. So each text is going to be a name. There's only going to be one, right? But I write the same code no matter what. I'm going to turn each one of those greetings requests into a call to the greetings service. I'm going to inject the greetings service here. So I'll say greetings service.greet gr. There you are. And from there, I'm going to take each greetings response, right? Each response that I get back from the greet call, I'm going to turn it into text. And then from there, I'm going to take each call that I get and I'm going to turn it into a text message. So session.textMessage text. Okay. And then from there, I'm going to send it. Okay. So there's my entire pipeline var, chat, I guess, whatever. Okay. And I'll send the whole thing back to the client using the API here. So session.send chat. Good. Now we've got our whole endpoint, as usual. Very, very simple thing, very simple code to write, not a big deal. In order to demonstrate this, of course, I need to have something that I'm not proud of. I need to do something I'm not proud of, something that I would not do if I could help it, if I could avoid it. But there's no other way that I can see to go forward. I need to write JavaScript. So I'm going to create a new source main resources static directory.
How could
and create
you,
a new
Josh?
file here. I know. Yeah. So WState HTML and body. Okay, and I'm going to create a script tag. And here I'm going to add an event listener. I'll say add event listener for load and e, and then const ws equals new WebSocket ws localhost orders. Okay, ws, not orders, greetings, isn't it? So there we are. And then from there, I'm going to add some event listeners to the WebSocket endpoint. So add event listener open. And that means that when I get an open socket, I can actually send data to the server. What I'm going to send is a name, right? So I'll say Spring fans, okay? Or actually, you know what? Better, let's do JNation. There we go. And then from here, add event listener message, and I'll respond as well. So now when the messages arrive, I'm going to log out the data that comes back, e.data. Now there's my endpoint. Let's go ahead and restart, and we'll load this up in the browser. Running out of time and coffee, not a good situation. You know what? I have this, isn't that weird? I have Chrome in the background here, but it doesn't show up in my alt tab list. See? It's Chrome. I don't know what's going on. Okay, localhost, ws.html, Command Shift I, localhost, oh, mea culpa. It's 80, restart. Sad, so sad. Okay, well, anyway, that's enough JavaScript for the year. So let's go back to this. Where do I have Chrome, whatever. Okay, so there's our endpoint. It's greeting us every second. and it's going to keep going forever and ever and ever. And that's okay. It's not blocking. That's the important part here. On the server side, we're not keeping a thread open. And so each time we send out a response, the thread is freed up and something else in the system is able to reuse it. This gives us much better scalability. The goal of reactive programming is not to handle one transaction faster. It's to make it so that I can handle many more transactions, right? With the same computer, with the same hardware. That's the real win here, is to reduce your data center spend and get better efficiency, take up less memory, et cetera, take up less threads, et cetera. This gives your application unwanted scalability. Now, I have a single service. Let's build a client to talk to it, okay? So I'm going to go back here. I'm going to use Java 14. I'm going to build an edge service. Now, this edge service is going to use the reactive web support. It'll use OurSocket support. It'll use Lombok, okay? And I think we could also use Resilience4j, the circuit breaker, right? We can also use Spring Cloud Gateway. There's a lot of good stuff there, but we're running short on time. So I'm going to go ahead and open up my edge service. Now, an edge service lives at the edge of the architecture. It's the first port of call. It's the wall through which requests from the outside world must pass in order to be able to reach your downstream services. So this is a great place to do authentication, to do load balancing, to do routing, to do circuit breaking, all sorts of stuff that you want to do to protect your homogeneous services that are downstream, right? This can also be a place to adapt requests coming in from the outside world, different kinds of clients, different kinds of payloads, different bandwidth constraints, etc. So you can handle all of that stuff here. So I've got my new application. I'm using the Spring Boot web support and the OurSocket support. So let's talk about the web support. What I want to do is I want to build an API adapter, or actually I just want to build a client to talk to that HTTP endpoint, right? So I'm going to say web client HTTP. I'm going to inject a reactive HTTP client called the web client, and I'm just going to build it that way. Okay, very, very simple. You can also configure things like client-side load balancing using Spring Cloud Load Balancer automatically as a filter here. You can do things like OAuth, protection and propagation. You can do that with a filter as well in a generic way, or HTTP basic or JOT or whatever. A lot of that stuff would just be done as a filter when you construct it with a builder, right? You can configure the filter like so, okay? But for our purposes, it's fine, it's unauthenticated. And then I'm gonna create a simple application listener. This is another event. You saw me use another style to create the same kind of listener earlier, right? Back here, I created a listener, event listener. There you go, I just use an annotation. This is the same thing, it's just an interface as well. So new application listener, okay? And what I'm going to do is when the application is ready, I'm going to inject my HTTP client and I'll write out some data. So when the application is ready, okay, ready, I'll say http.get.uri, http localhost 8080/reservations. And the data that's going to come back is going to be JSON. I'm going to turn each JSON record into a reservation object. But of course, in order to do that, I need to translate the JSON into a DTO. And I'm going to use a compiled type to do that. So I am going to do something terrible, something that you should never, ever do, ever. Not even when you're all by yourself at home and no one is looking. I am going to copy and paste code. So here we go, Command C. And I'll go back here and we'll paste, okay? So there's my types. And now I've got the reservation type on the class path. And I'm going to take each one of these. I'm going to get the name. So I'll say for each R, give me the name. Okay. And I'm just going to log it out. So I can do an adapter. I can create a little adapter that prints out information from the service, right? This is a great thing to do as well. You can return, remember, this is just a reactive stream right here, right? If I actually assign that to a variable, it's just a reactive stream. So I could actually create another HTTP endpoint or a WebSocket endpoint and return the data from this, right? I just take the publisher that I'm receiving and then pass it back to the thing that's expecting it. This is what I mean by easy composition. Now I've got this reactive API. I've got this reactive publisher. These publishers, these reactive types from Reactor, Flux, and Mano, very, very convenient, right? Very, very convenient types. Lots of support for building in more robust code. I can do a retry. I can retry 10 times. I can retry and then do a backoff. So like this, retry dot backoff, 10 duration dot of seconds, etc. I can do a on error resume. So if something goes wrong, I get a callback and I can return a default value. So here I'm controlling what value the client will see. Instead of getting a big fat Java stack trace in the client, I can see what's happening and I can control the rate of degradation. I can also do timeouts, but timeouts are not the best way to solve this kind of problem, right? Think about what I'm trying to do here. I want to guarantee that my consumer, the consumer that is calling this edge service, gets a response back within a certain amount of time. I want to guarantee that they get a certain amount of time. So imagine what I will do. I will say, oh, well, I must call the reservation service. The reservation service, if my deadline is 20 seconds, which is crazy, nobody should take that long ever, right? Even PHP code should be faster than this. But let's say it's 20 seconds. If I have 20 seconds to respond to my client, then I must make a call to the downstream service and get a response in 10 seconds. Because if that fails, I want to try one more time. That's why I have 10 seconds. Well, what about the service after that? It must call another service and get a response in 5 seconds, because it has to be able to fail and then respond within 10 seconds. What about the service after that? Well, 2.5 seconds, right? So the time decays very, very quickly. And so this becomes very unfair to services that are a few hops away from the edge. And it doesn't really solve the problem. A much better pattern is to use hedging. Hedging is where you, in English, when you say you're hedging, you hedge your bet. When you gamble, you do not put all your money in one color. When you invest in the stock market, you don't put all of your money in one stock. You hedge your options. You hedge your bet by not putting all of the risk in one option. So what I'm going to do here is, instead of calling one service, I'm going to call 3 services, okay? I'm going to call 3 instances of the same service on different hosts and ports. And of course, to do that, to get different hosts and ports, you can use the Spring Cloud Discovery Client, but I don't have that configured. So let's, for now, just imagine that you have 3 different instances, okay? What I want to do is I want to take a call from host 1, like this, okay? And host 2 and host 3. So 2 and 3. There's my 3 different hosts, and I'll leave it to you to imagine all of this. Remember, there's no network IO yet. Nothing happens until something subscribes. So I'm defining a pipeline, and here I've defined pipelines. Let's imagine I've called host 1, host 2, and host 3. I haven't made the call yet. Now I want to tell the Reactive API to give me the fastest stream to return, right? This is actually a great example. I'm saying call all 3 services at the same time concurrently, and then the first one to return bytes, keep that one and apply back pressure to the other 2. I'm using 3 hosts, but it could be 4. It doesn't really matter, right? The API doesn't care. It's just I'm using 3 as an example. So very, very useful pattern, very natural pattern to express in a Reactive API. It's a one-liner. Can you imagine how hard it would be to write that code in blocking traditional IO and APIs? It would be a nightmare. You'd have thread locks and countdown latches and cyclic barriers and so on. So Reactive APIs makes it very easy to do service composition and scatter, gather kinds of interactions, right? A very interesting project that I've seen out there is called Assembler. It's a third-party project. It builds on top of these Reactive APIs. There's an integration for the Spring WebFlux reactor types. And so you can create a logical transaction. You can say, this is called transaction, but it's a domain type. It could be an order or any kind of aggregate. Here, I'm creating a logical transaction of T, and then I'm defining rules to create a assembler that has one-to-one, one-to-many, etc., and then uses this constructor. So I can do scatter, gather kinds of operations over the network and create one single response. And it's very imperative, very simple to read, very easy to read, and yet I get concurrent IO. So that's very convenient, and it's only possible thanks to these nice Reactive APIs. So that's one stream, okay? Now, I like HTTP. The problem is that HTTP has very serious limitations that limit its ability to scale, right? And so a lot of different organizations have gotten around this. This is the problem. A lot of different organizations have gotten around this by creating other protocols. Google created gRPC, and if you want to use gRPC, you can use the Salesforce Protalk compiler plugin to integrate gRPC with Project Reactor. It'll code generate reactive gRPC services. But my favorite technology to solve these kinds of problems is OurSocket, which was developed by Facebook. OurSocket is a binary protocol that you can use to stream data over the wire in a protocol and platform agnostic way, and it doesn't care what the data that you're sending across the wires. It can be binary, it can be JSON, it can be XML. It supports bidirectional communication, full bidirectional multiplexed communication, which gRPC does not, HTTP does not, etc. They support at best pipelining. So very, very efficient protocol. That's all I have to do to make this work. I'm going to start up an RSocket service here. The Java binding for RSocket when the Facebook developers that came from Netflix who built this, when they built it on top of Project Reactor. So we've already got an easy integration, but it was easier now because in Spring Framework 5.2, we actually integrated it into the platform. So we actually have a component model that you just saw me use to create this. So now I'm going to create a OurSocket endpoint, OurSocket ready, and I'm going to use an OurSocket requester. Okay, and so this requester is not, it's, there's no such thing as client server in the OurSocket world, because once things connect, they stay connected, and either side can send a message at any time to either side. So it's not client server, it's requester responder. But the construction of the OurSocket requester is very similar to the HTTP web client. So I'll say builder.connect TCP localhost, and I said 7777. And also here too, I can do metadata, I can do credentials, I can do authentication, I can do simple authentication, which is kind of like HTTP basic, or I can do JWT, and I can do that at the creation of the connection, or on each transaction, on each request. Remember, when the OurSocket client and service, when the requester and the responder connect, they stay connected through the life of the application. They don't have to reconnect each time. That makes it even faster. So what I'm going to do is I'm going to make a call to host import 7777 to the greetings endpoint. I'm going to send in a new greetings request, JNation, right? And then I'm going to expect a stream of responses back. And then for each one of those back, I'm going to subscribe and then print out the data, okay? So it looks like that's it. Let's go ahead and run it. We've got the route, the data, the response back. Yeah, good, run it, okay? So my friends, I hope you've gotten something out of all of this discussion. We should see two things happening right now: a stream of reservations and encountered an exception. Oh, wrong HTTP port. I'll bet you. Server.port equals 9090. Okay, restart. I hope you got something out of all this. Obviously, we've covered a lot here. We covered Reactor, we covered reactive data access, we covered SQL and NoSQL, we covered patterns that you can use. There's the data. There's our 8 records from the service, right? That came back as we expected it to. But then, then you can also see our reactive never-ending stream of data being sent over the wire reactively through this OurSocket protocol. So I'm making an OurSocket request, and at the end of the day, all I have are publishers. This is one of the real benefits here, right? Is you get efficient end-to-end reactive programming and the publishers all the way through. So we looked at SQL, NoSQL. We looked at HTTP functional reactive endpoints. We looked at WebSockets. We looked at service orchestration patterns. We looked at patterns like hedging. We looked at HTTP clients and OurSocket. I hope you got something out of this. Thank you so much for your time. Brigado, everybody, and I'm happy to answer your questions.
Thanks very much, Josh. Great session. You covered a lot. So we have a few questions. The first one is from Bruno Barin. There's a lot of Brunos around. So he's asking, what are the benefits of combining Kotlin coroutines with reactive streams?
Great question. I didn't even have time to talk about that or do a demo. Coroutines in Kotlin are a way to write imperative-looking code that looks like it's line. It has the normal. Line 1, line 2. It looks like that, right? But behind the scenes, you get the benefit of having done callback style kind of code, right? And so instead of doing this, you can actually, it looks more like that. So behind the scenes, it rewrites your asynchronous code into behind the scenes. It rewrites your imperative sort of deterministic step 1, step 2 style code, and it rewrites it as callback centric code. That callback is called a continuation. It's one part compiler trick, one part asynchronous programming. Well, if you know Reactor, if you know these reactive types, everything in Reactor, in Kotlin, everything that is based on these reactive streams types automatically can be used as coroutines. So instead of writing all this code using these APIs, the then, many, and all that stuff that I showed you, you can just write line 1, line 2, right? You can just stream these things together naturally. This may be asynchronous. It may stop. It may move to another thread. It may take a week to finish, but the function execution will suspend, and when it's done, it'll pick up here on line 2, as though it was still in the same thread, but it's not. It could be a week later. It could be a completely different thread. You don't even know. Doesn't matter, right? Really amazing integration, and it's just automatic. If you're using Kotlin and you're using the Reactive Spring support, you don't have to add anything custom to the class path. Just go to start.spring.io, choose Reactive Web and Kotlin, and we'll automatically have everything you need to be able to get started with that. It's awesome. So, and I did a Spring Tips video on that as well.
Cool. So Bruno Barin and João Rebelo have a similar question. So it's will Project Loom supersede reactive streams, or how will they compete or complete themselves? So how will it work? How will it work?
I think Project Loom is just going to make things even better, right? So that'll solve one of the problems, which is that threads are expensive and we need to be more careful about reusing them, right? The other problem, it hasn't been solved yet. There still doesn't give us a great control flow mechanism, right? So how do I deal with services over the network that are going to fail? There's no good API for that still, right? So this gives us having, and also the fact that every API is still every API means that you still have a lot of APIs to learn. Whereas with reactive types, you have just one uniform interface, which I prefer, right? It makes life much simpler to reason about. I'm getting older. My brain is not so good. I appreciate having just one thing I can work with to solve most of my problems.
Cool, Josh. Just one last question. So what about debugging this kind of applications?
Yes, I did a Spring Tips video on that as well. I showed you the blockhound as well, but there's also a bunch of things you can do. There's onOperator.debug, which is a method you can call to force each pipeline to emit information. It's very expensive at runtime, so you don't want to keep it in production, but it'll capture the full assembly stack. So instead of just a stack trace, it'll actually capture the whole assembly trace, which is the pipeline, the whole pipeline. It'll capture all the movement of data from one thread to another. Instead of just showing you all the threads in all the invocations in a current thread, it'll show you all the different invocations across the whole pipeline. There's that. We also have a Java agent that you can use to actually build that into the code at compile time, which means that that'll actually, that'll make it a little bit faster, but you're still capturing extra data. So be wary of that. We also have, I showed you block count, and also debugging still works, right? You can actually just put a breakpoint here, and actually that's not a good example. Where's my lambda? Here. Well, you need a method.
We'll have to check it some other time. Maybe next year here live in Coimbra. Because we have run out of time and we need to go to the next session. So, Josh,
thank you so much.
Wonderful session. Thanks very much for being here. And well, you're welcome to come back next year.
I appreciate it. Hopefully we'll see each other again. And I encourage you to follow me on the internet if you're there. Okay. Thank you.